Tonight we're going to continue our discussion on surface area, and tonight finally you're going to hopefully feel like, oh, maybe we touched upon composite figures in 6th grade, but wow, finally I feel like this is new material. So we're going to talk about the surface area of composite figures tonight. So our objective is still I can find the surface area of any three-dimensional figure, and we're going to focus on composite figures. Composite figures are just figures made up of two or more three-dimensional figures that you know. Like here, this composite figure is made up of a rectangular prism, it's made up of a cube, and it's made up of a triangular prism. Here, this is a rectangular prism with a triangular prism. This is a rectangular prism with a couple of cubes. We're also going to throw some pyramids in tonight. So that's all a composite figure is. It's made up of several three-dimensional figures you already know about. And now you're going to find the surface area of those. So let's just jump right in. Determine the surface area of the following figure. Now, a lot of times in actual problems, like on a state test, they might tell you they're only painting the lateral faces, which for this case would have meant the 4 rectangles making up the outer edge and the 4 triangles making up the top edge. Like they might not be painting the bottom of this figure if it's sitting on the ground. But maybe this is a toy that you have to paint the outside of or wrap the outside of as a special little gift. So they want us to find the area of every surface and then add them together. Now the only surfaces we don't need to worry about are the surfaces where they're connected. Certainly don't need the base of my rectangular pyramid or the top of my rectangular prism, because those faces aren't exposed to the outer world. So hopefully you can see this. This is a solid figure, and we're going to just do the outer portions to wrap. Okay, so I'm going to focus first on the top triangular, or I'm sorry, the top pyramid, that rectangular pyramid. I don't have to worry about the area of the base of that. I just have to find the area of the 1, 2, 3, 4 triangles. And for the area of those 4 triangles, I can tell you the base of the triangle, if I slide that 9 up, is 9 feet, and the height is 6 feet. Again, if I slide this 9 up, that's 9 feet, and the height has to be 6 feet, so they come to a beautiful single vertex at the top. So these 4 triangles are actually going to have, each one of them will have the exact same area, and we have 4 of them. So I'm going to do the area of a single triangle and then just multiply it by 4 because I know I have 4 triangles going around the top. So the area of the triangle is 1/2 times base times height. This is 1/2. We know our base is 9 and we know our height is 6. Base of the triangle is 9. The height has to meet the base at a beautiful right angle. So I can multiply these in any order based on my commutative property. So I'm actually just going to multiply 1/2 by 6 and get 3. 3 times 9 is 27. Just to make my multiplication easier, you could have done 1/2 times 9 is 4.5. 4.5 times 6 must be 27. You could have done 6 times 9 is 54. Half of 54 is 27. Lots of ways to multiply those 3 numbers or pick up a calculator. So that's feet squared. Feet times feet is feet squared. So if you have 9 feet times 6 feet, you have feet squared here. All right, and there's 4 of those. So the area of just one of those was 27. I have to do 4 times 27, and because I am a little bit old and a little bit lazy, now I'm going to pick up my calculator. 4 times 27. 4 times 27 is 108. So 108 square feet for the 4 triangular faces. All right, so now I have to worry about that bottom. Well, the nice thing about the bottom is if this is a 9 by 5 rectangle, and I know my height is 5, and the bottom's actually a square, then this is also a 9 by 5 rectangle. And if I drew my little rectangle in over here, That would also be a 9 by 5 rectangle. And if I drew my last rectangle in along the back there, not the most beautiful picture I've ever done, but if I drew my last rectangle in the back, that also has to be 9 if I slid that 9 back by a height of 5. So the beautiful thing is that these 4 lateral rectangles actually match. So now I'm going to find the area of my 4 lateral rectangles. Only because they all match. And then I just have to find the bottom of my rectangular prism. So those 4 rectangles, the formula for the area of a rectangle is base times height. The base is 9, the height is 5. 9 times 5 is 45. 45 feet squared. And I actually have 4 of those. We just discussed the fact that around the outside, all 4 of those rectangles match. So I'll just do 4 times 45. I think it's 180. Here's what I did in my head. I did 2 times 45 is 90. So 4 times 45 is double 90 is 180 feet squared. But go ahead and check that on your calculator. 45 times 4, 180. So those are for our 4 rectangles, 4 lateral rectangles. Now I just have to do the bottom, the base of my rectangular prism. So if I have to just paint out the bottom now, the area of the bottom of my rectangular prism, the area of a square can be side squared or base times height. The base and the height of that bottom is 9 by 9. 9 times 9 is 81. 81 feet squared for the bottom. I don't have to worry about the top of the box. I don't have to worry about the bottom of the pyramid because those are actually both inside this solid figure. And I only need to paint all of the outer faces. So now I'm just going to add up the area of the base of my rectangular prism, the area of my 4 triangular faces, and the area of my 4 lateral rectangular faces. That'll give me my total surface area. 81 feet squared plus 108 feet squared plus 180 feet squared equals, sorry about that, my bad. My bad. Sorry about that. Okay, I'm going to add all those together, and I'm going to get 81 plus 108 plus 180. 369 is what it looks like to me. So 369 square feet would be the surface area of the outer surface of this beautiful composite figure. All right, let's try one more. This might be how the word problem looks like on like a state exam. The structure below will be built for a carnival. The exterior surfaces are going to be painted. What is the total area of the exterior surfaces that need to be painted? Show your work. Okay, so first of all, this is made for a carnival. It's going to be built on the ground. You don't have to find the area of the base. And on the last example, I still made you find the area of the base. But this I can see in this word problem. If it's a 10 foot by 10 foot, this is a bigger structure. They're not going to find the area of the bottom base because all they want is the exterior surfaces once the structure is painted. So I'm not going to find the area of the bottom base. Let's hope I'm looking at this problem correctly. All right, so I still have to find the area of my 1, 2, 3, 4 triangles up top. So let's take a look. The base of each of those triangles, if I slid up this 10 foot, would be 10, and the height would be, it looks like 13. So it looks like 10 by 13 will be these triangles. So let's find the area of our 4 triangles. area equals 1/2 times base times height. 1/2 times the base of that triangle is 10 feet times 13 feet. Area will be 1/2 times 10 times 13 is 130. 130 feet squared. Half of 130 is half of 130, 65. Ooh, let me double check. 130 divided by 2. Yeah, 65. Half of 130 is 65 feet squared. That's for one of the triangles. You know we have 4 triangles on the exterior here. So we do 4 times 65. I think that's going to be 260. Don't quote me. 4 times 65. Of course it's 260. 260 feet squared. What I did was I said 2 times 65 is 130, so I doubled 130 and got to 260. So there's for my 4 triangular faces. That's our total area of our 4 triangular faces. Okay, so now we just have to find the lateral faces of this rectangular prism. And the nice thing is I can see for these lateral faces, 12.5 by 10 is that one. These 4 match also. And this is 10 by 12.5. This doesn't always happen, but all 4 lateral faces actually have the same dimensions, 10 by 12.5. This could have been wider along the bottom, and then front and back would match and sides would match. But in these examples that I pulled offline and obviously didn't really look closely at, the lateral faces keep matching. So the area of our 4 rectangular faces that we care about, because we're not going to worry about the bottom because it's sitting on the ground. So the area of our 4 rectangular faces is base times height. We just figured out that the base of each of those is 10 feet times the height is 12.5 feet. I'll use estimation in my head at first. 10 times 12 is 120, so if my answer doesn't come out near 120, I know I have a problem. 10 times 12.5, 125, beautiful. 125 feet squared. That's for just one of our rectangular faces here. We have 4 of them. So 4 times 125. 4 times 125 is 500. And the sad part is, I really normally would try to avoid examples like this because kids always assume all 4 lateral faces on a rectangular prism match, and in general they don't. Oh well, tonight's they did. So these are our 4 rectangular faces. That's the total area of our 4 rectangular faces. Now, to find our overall surface area that we have to paint, you might have to figure out how many, gallons of paint you need. And then on a gallon of paint, it'll tell you how many square feet it can cover. So we just have to add up the area of our triangular faces and the total area of the 4 rectangular faces I need to go ahead and paint. And so 760 square feet is what you'd need. So then you'd go to the store, you'd say, how many square feet can a gallon cover? If a gallon covers 200 square feet, I have no clue. You'd figure out how many gallons of paint you'd need to buy. You'd need to buy 4 because you need a number that's greater than 760 square feet. All right, hopefully that helps a little bit. A reminder of surface area, but now with composite figures. Have a good night.